Hi, I'm Paul, and we're doing Leetcode must-know interview questions. Today's challenge is merge K sorted lists. Um, Rating hard, probably because the obvious ways of solving it are not going to work in a reasonable amount of time. So you are given an array of K linked lists called list, variable name list. So let's see, scoot this over a little bit. Yeah, here's the method signature, merge K list, and we get an array of lists. Lists are made up of list nodes, and we're provided with this list node class, which has some constructors, and it has two properties, a value and a pointer to the next to the next node in the list. All right, each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. Okay, well, so there's a couple, kind of obvious ways of approaching that. One is to just merge the lists one at a time. The same way we would merge like two sorted linked lists. Okay, so we'll take two lists and merge them, and then we've got a result list. We'll take the third list and merge it into the result list. Take the fourth list, merge it into the result list, and so on until we're done. So what would the runtime be on something like that? So the number, let's look at the constraints here. All right, so K, we're going to let K equal list.length. That's the number of lists that we have. And that number can be anywhere between 0 and 10 to the fourth, which is 10,000. Number of elements in a list can be between 0 and 500. Okay. All right, the runtime, let's look at why this is not going to work. If we have one list, now what is the length of the list? Well, the lists don't have to be the same size, but to simplify things here, let's say that the length of each list is n. I mean, we could say they're all the same length, they're n, or we could say the average length is n, but we need something. So let's say if we just have one list, that would be n. Now, once we merge two lists, we are going to have to process 2n elements. Once we merge a third list, we are going to have to process 3n elements, and so on until we get to the last list, and that would be kn. All right, and that's the total number of elements that we have. Number of lists, which is k, number of elements in each list, which is n. What does that come up to? Well, it's going to be n times the sum of all the numbers from 1 to k. And then the formula for that is k times k plus 1 over 2. Okay, and that would be O of k squared All right. So the whole thing, wow, that's not a very good 2. The whole thing is going to come out to O of n times k squared. All right. Why is that bad? Well, you look at k here. That can be up to 10,000. What is k squared? So 10,000 squared. We need 8 zeros. That is 100 million. Is that right? Yeah, 100 million. And n, what is n? Well, n could be up to 500. So 100 million times 500 is 50 billion. 50 billion operations. That's not gonna work. All right, so let's toss out that approach. Another approach that is not going to work would be, again, to merge them like we would merge two linked lists. I mean, the way we would do that is, say you've got two lists, look at and they're sorted. So look at the first element in each list. Which one is smaller? Take that one and add it to the result list. Move the pointer forward on that list. And keep going like that. All right, now which list is the first element smallest? Okay, so we'll take that one, put it in the result list, go forward. So we would have to do that for each element, and the number of elements is n times k. And so we would have to do, because there are k lists, we would have to do k comparisons for each element. So again, that turned out to be O of n times k squared, 50 billion operations. It's not going to work. All right. The way I usually have seen this solved with Java anyway, I mean, Java has a built-in data structure called a priority queue, which means you can add things to the priority queue and it will order them without you having to do anything. So you could just feed elements from these lists into the priority queue and they would come out in order. But because this is under the divide and conquer, category, I don't think that's the solution that they want. If you run into this and you have to do it, take a look at the priority queue method for doing it, because that's a pretty simple approach. But we're going to do it a different way. Let's move this over here. So the idea that we're going to try to implement is let's merge pairs of lists. Okay, so we can merge, and if we use the array index in lists. So let's say we merge list 0 and list 1, and we also merge list 2 and list 3, and we also merge list 4 and list 5, and so on. So we've got, once we finish doing that, now we've cut the problem space in half. We only have half as many lists. All right? Now, we're going to go through and we are going to merge list 0 with list 2, and list 4 with list 6, and so on. And again, we cut the problem space in half. We'll talk about the runtime when we finish it, but it's not going to be k squared. It's going to be a log k, because we're cutting the number of lists in half every time. I think it's going to be n n log k. N, no, I'm sorry. You know, nk log k. Let me think about it. Anyway, so here's what we're going to do. Merge k lists. All right. We need to know how long. We need k really. So let's say int k equals lists length. Okay. Now for loop here. Say for int. I will call it gap equals 1. We're going to start out with a list adjacent to each other, separated by 1. Gap is 1. Gap is less than k. And gap we are going to increment. Actually, multiply by 2 each time because we're cutting the number of lists in half. All right, gap less than 2. Okay, now for int I equals 0, I plus gap is less than k, I plus equals gap times 2. Now, is that going to work? So the first time we come through, all right, so gap is 1, and then we're going to go through and merge all the lists. I is 0, I is 0, and then we can use I plus gap. So we'll merge 0 and 1, we'll merge 2 and 3, and so on. Wait. Yeah, that's right. Because the first time through, I is going to be 0, and we'll merge 0 and 1. And then I is going to equal I plus gap times 2. First time through, gap is 1, so we're going to add 2. So we're going to merge 0 and 1, and then we're going to merge 2 and 3, and so on. So that should work. And we'll say array. Wait a minute, not array. Lists at I equals merge 2, which we have to write. It's going to merge lists I, and it's going to merge lists I plus, no, is that a 1? I plus k. Okay. Good. Second time through the outer for loop, gap is going to equal 2. So we'll come through it again. Well, and now what are we going to merge? We're going to merge I will equals 0, and we are going to merge list 0 and list 0 plus gap, which is 2. 0 and 2. Yeah, that's right. And then increment I by 4, which is right. We'll merge 0 and 2, and then we'll merge 4 and 6. Okay, yeah. All right, so what's left? What's left is merge 2. Okay, and actually, let me move this because I'm going to want that in a minute. Okay. So let's say private, and this will return a list node, and we'll call it merge 2. Okay. List node A, list node B. All right. This is going to be recursive. Here's a base case. If A is null, then return B. Okay. If B is null, return A. Right? Now we got to do comparisons here for the merge. So if A dot data. Now this is different. Merging linked lists. It's different than merging like sorted arrays. If we were merging sorted arrays, we'd have to take the numbers out of the arrays and put them into a new result array. But if we're merging linked lists, we just have to move the pointers around. So it's different. So if a dot data is less than or equal to b dot data, we can say a dot next. That is, we're just going to change the pointer. So a dot data, if the first time we come through here, if a dot data is less than or equal to b dot data, then the first node of A is going to be the first node of the merged list. All right, and then we'll set the pointer to, and we can call it recursively, merge 2. We'll send in A dot next, and we'll still send in B because we're not doing anything to B. We will also return A. Why are we returning A? Well, when the recursion unwinds on this, we're going to get a lot of returns. Okay, we're going to go through, we're going to make a lot of recursive calls, and then it's going to unwind. We're going to get a lot of returns, but the last return that we're going to get is this one here. Or, you know what? Maybe I shouldn't say that yet. Let me finish it, and then I'll continue with that. This is going to be very similar. If what's that? If b dot next is okay, b dot next, else b dot next merge 2, and we'll send in a and b dot next and return b. Okay. Thing is, the first time we come through here, that is going to determine which node is the first node of the merged list. All right, if a dot data is less than or equal to b dot data, then the first node of A is going to be the first node of the linked list. And so we want to return A. If A dot data is greater than B dot data, then the first node of B is going to be the first node of the merged list. And so we want to return B. So that's what's going on there. Let me do a quick summary here. We can use the practice practice. Let's see. Let's go here. Yeah, that should work. So let's use these practice lists here, like 1, 4, 5, and 1, 3, 4. So A will be 1, 4, 5. B will be 1, 3, 4. All right. So we come through this routine. Is A null? No. Is B null? No. Is A dot data less than or equal to B dot data? Yes. All right. So that means A dot next is going to point to whatever gets returned from merge 2. Merge 2 is going to be the lesser of A dot next, which is 4, and B, which is 1. So that means that this is going to point to this. Okay. So we come in, let's see, we come in with 1 and 4. 1 and 4, is A dot data less than or equal to B dot data? No. All right. So B dot next is now going to point to the lesser of A and B dot next. Okay, which would be 4 and 3. We're going to come in with 4 and 3, and it is going to point to the 3. All right. We come in with 4 and 3. B is less. All right. So then B dot next is going to point to the lesser of A and B dot next. Well, the tiebreaker because of the less than or equal to goes to A. So that pointer is going to go up here. We're going to come back in with, let's see, 5 and 4. Merge to A dot next is 5. B is A less? No, actually B is less. So that pointer has to go here. All right. We come in the next time with A dot next, which is 5, and B, which is null, actually. So that's the end of the line. We just return A. Now it's possible that the lists are not the same size. We run out of nodes in B, we'll just send everything that's in A. In this case, it's only one node. So it's going to point like that. So that's how the merge 2 works. We're just swapping pointers. All right. So let's take a look at this. I'm going to turn that off. So we come in. We are going to have to process. Actually, yeah, we're going to have to process the. Well, let me stop for a minute and collect my thoughts. Okay, let me say it this way. This outer loop here. The number of lists gets cut in half every time. So how many times do we go through that outer loop? We go through the outer loop log k times, base 2 log of k. What happens in the inner loop? Well, in the inner loop, we're going to have to process all of the elements every time. So that's n times k. So the runtime, I shouldn't get to the runtime until I make sure this actually runs, but the runtime would be n times k times log k. That said, let's see if it runs. Compile error if, what? Line 17. If, oh shoot. It's not called data, it's called val. All right. Val. Okay. Val. What can I select that whole thing? Val. All right. Okay, good. Start one more time. Compile error, missing return statement. Oh. On 34. Oh, okay. Yeah, hang on a second. Okay, yeah, it would be good to return something here. Actually, let's look at the constraints again. It is possible that K can be zero. In other words, that there's no lists. So it's probably better to handle that um, as an edge case up front and say if K equals zero, turn null. All right? And then down here, we'll say return lists at zero. Notice that we are always putting the merged list back in list zero. Okay, let's try it now. Okay, all right, that's good. I guess that's not right to say we're always putting it in lists zero, but we're always putting it in the first list. That is, we're going to return a merged list, and we're going to put it in the first of the two lists that we're merging. So eventually we'll get it down to two lists, which would be list zero and some other list, and that the final merge result would go into list zero. All right, submit. Okay, that's interesting. Okay, well, it's a pretty narrow set of runtimes. I mean, I think it's that unless you do it, I mean, you can do it like this. This is the divide and conquer. You can do it with a priority queue. I mean, I guess there's no rule against that, but um, that's also the priority queue is also actually, let's get what is the runtime? What did I say it was? Like nk log k, k times n times log k. Yeah, that's the same as the priority queue. So I guess you're going to get a narrow set of runtimes. If you try to do it one of the other ways that we talked about at the beginning, that where you've got 50 billion comparisons, I think it's just going to time out and fail. So that's why we get a narrow range of runtimes. All right, that's it for merging K sorted lists. I hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.